You may know them for their wood glues, but did you know Titebond also has a complete selection of construction adhesives? Designed for a variety of applications, Titebond's adhesives make any building or home improvement project a breeze with their high-performing and durable formulas. These adhesives are trusted by the professional, providing squeak-free subfloor installations, long-lasting retaining walls, and even fastener-free feature walls. Check out Titebond's construction adhesives at titebond.com, including their newest award-winning adhesive, Tight Grab Plus. Our next question comes from Jim, who put this on the Fine Homebuilding Forum, and we should mention, Ian, you've been moderating the Fine Homebuilding Forum. You want to talk about that?
Yeah. I must have done something to irritate Brian, because he gave me that as a task to do at the beginning of April. At least that was my joke, but it turns out I'm actually really enjoying it. There's a lot of great people that comment on questions, and just great questions from people who read the magazine, and the website get posted on there every day. So it's a great way to interact with an intelligent group of people. It's a little bit different than the GBA forum, as Randy knows, but you can get some good advice from people.
It's a community is how I would describe it. This comes from Jim. Hey, all, I'm looking to add an LVL beam to support my second floor joist in one of the rooms. To support this LVL beam, I'll need to add a Lally column from the basement that goes all the way up to the ceiling of the first floor, which is about a 16-foot rise. I know it's not a good idea to stack two Lally/jack posts. What are my options? Two 8-foot sections of square tube that's welded together, or one Lally column secured to the floor joist of the first floor, then adding a second Lally column on top, creating two independent columns? So, Ian, how would you do this?
So we do this all the time on our projects, as you know, in remodeling, when you're changing around room footprints, and you end up having to post new loads down. And the advice that I gave to Jim was start at your floor in the basement. So we typically cut a square out of the floor, and we dig down and we pour a new footing. The column gets set on the footing, and then depending on where the floor system above lands for the first floor, we'll either double up a floor joist, or we'll put some squash blocking in if that's what seems to work best for that install. And then above it, we've actually switched to using PSLs. And the reason that we've switched to that is we found our engineering professionals were typically specifying those. And when you have one of these point loads that has been engineered, the building inspector is really just coming to look and make sure you did whatever the engineer said. And through doing enough of these posting down, we found that the crew really liked the PSLs. They're stocked at our local lumber yard. They're not terribly expensive, and they're a really dimensionally stable, straight, and easy to use product.
We should tell folks who might not be familiar, PSL is a parallel strand lumber, and it's often a beam, but you can also make it 3.5 inches square, and it's a post, right?
Yeah, they work great for these instances, and the fact that they're straight, and just, you can't beat it.
And you can screw it to what's there, which is, it's more difficult to integrate a Lally column into wood frame construction.
Yeah, and the other thing I learned from building my house, because I used LSL studs for a lot of it, was my building inspector just came in and said, yeah, you used engineered material for everything. Good on you. I don't really have much to look at here. So it is something that can give your building inspector the peace of mind that you're doing the best work that you possibly can, especially in a tricky install like posting down a new bearing load.
Randy, how do you like to see this done, or how do you like to do, long load pass from the second story down to the basement?
Yeah, if you're in the middle of a house, that's what Ian did, especially in a renovation. I don't know what else you'd do. You can't make that one continuous piece. It's going to be two pieces. And we really don't worry too much in the middle of a house. We don't have a shear twist load there. It's just a bearing point, that weight coming down, and we just want to transfer down all the way to the basement. And when you get into an outside, like for instance, I sent you a couple pictures of, or one picture of a tall wall that we had to build, where it was basically balloon framed. There were a lot of windows in it. It was engineered by my local lumber yard. They sent the drawings to we used LVLs to the manufacturer of the lumber. They designed the system, and then I just built it to their spec. I think we had 24-foot LVLs. I think there were 2x6 LVLs that went from the floor to the roof. They supported a big beam at the roof line. The challenge was, of course, putting all that together. A wall that's
picking them up would be
yeah. Well, and I had a piece of equipment which helped, but the two of us did it. I think the sidewalls in that house were 10 or 12 foot, and then we had a 10, 12 pitch roof on top of it. We had to stand all that up in one shot, 24-foot long wall. I had my rough terrain forklift or lull there, and we picked it up in one piece and set it down. And my 18-year-old son at the time, and myself did it by ourselves, and it worked. But yeah.
Ian, you answered the question to a degree in your response about this, but the PSL. A lot of folks would be tempted to, just spike together 2x4s, which is something carpenters have done throughout history, right, to create load paths. But you like this because the PSL, because of its straightness, and primarily because this is what the engineer is going to put on the plans anyway.
Yeah, and when you think about the deflection of 2x4s just spiked together versus the PSL, depending on the load that you're putting on it, you're not going to get any deflection out of that PSL the way that you would to construction grade 2x4s spiked together.
Randy, it's probably of little concern in the greater scheme of things because, making houses that stand up and are safe is far more important than thermal bridging. But what the heck do you do about that giant post that, in the case of your building, goes all the way from the basement up to the second story roof? To prevent its thermal bridging. And I mean, this is a problem with studs too, but what do you do, or can you do anything about it?
Yeah, and that house was actually my first continuous exterior insulation house. So that's
the solution.
Yeah, that's how we dealt with it. Yeah, learned a lot on that one. That was back in 2013, and like I said, we were using XPS foam. We used 1.5 inches on the exterior of the structure to help alleviate that. Yeah.
Is that something you guys have the luxury of worrying about, Ian, when you're, remodeling people's old houses?
Typically, no. You kind of have to do whatever an engineer, a design professional, or carpenter know-how tells you have to do in order to execute the job. I did say to Jim in my response on the forum that when he brought up I believe the tube steel welded together, I have done that in a commercial setting when we added I think a 4-story elevator shaft to a building that didn't have one, that was being converted from industrial space into kind of residential mixed use space. And there was a lot of steel and a lot of bolts, and that was kind of a fun project to be involved in, but I think it's overkill for a residential application.
Overkill for a residential application. So I'm glad that's a perfect segue, because many engineers are going to be familiar with commercial or industrial work, and they're going to specify these steel posts in a residential project. Is there any way to get them on the right path so they don't specify something that's outside the ordinary?
We try and give feedback to the people that we're using, and because we're a design build contractor, they are somebody that we're seeking out and hiring. So that does give us the opportunity to have a conversation with them about our preferred means and methods so that they can try to use those methods and those products in their engineering work. And that's really where the PSLs came from originally. Was one of the guys in the field was like, they have these at the lumberyard, why don't we use them? And then we come to find out they can carry quite a lot of load. So they fit these situations.
And the values are very easy for engineers to use, right? The quality of lumber, requires safety factors, and
yeah, whether it's Weyerhaeuser or LP, whoever makes the one that you can buy locally, you can download all the information that an engineer or a building inspector would ever need to know about the load ratings of that composite material.